Let's unravel the mystery behind coma, an aberration that can turn point sources of light into a comet-shaped blobs, leading to significant image degradation. What's coma, you may ask? So, coma primarily affects light rays that enter a lens or a mirror at an angle, away from optical axis. So, as you can see here on this diagram, the unique characteristic of coma is that different parts of the lens or mirror magnify the incoming light by varying amounts. This unequal magnification causes the off-axis image of a point source to spread out asymmetrically, resembling a comet with a tail. Coma primarily affects light rays that enter lens or a mirror at an angle, as you can see here. Well, we can also observe coma on the real image. So for example, let's take two systems, one perfect, well-aligned optical system, another aberrated, misaligned optical system. Well, you can see that images on the right-hand side perfectly illustrate this effect. We see the ideal diffraction limited point speed function here when the laser beam passes through the center of the lens, which is aligned. On the other hand, when the lens is misaligned, we see the coma-shaped aberration. Coma arises from geometry of spherical lenses and mirrors. The further away is from optical axis, the more is bent upon entering the lens or reflecting from the mirror. This leads to different focus points for different parts of the beam. The resulting image is a complex pattern of varying intensity, with the brightest spots toward the center, a tail extending away. So, consequences of coma are blurred images, which can significantly degrade image quality, especially towards the edges of the field of view, as you can see here. For example, star can appear elongated with elongated streaks, and detail become indistinct. The effect of coma can also be reduced contrast. The overlapping tails of multiple coma patterns can reduce contrast and obscure fine details. How we can correct coma? Well, we correct coma by using parabolic mirrors, for example, in telescopes. These mirrors have a more complex shape that ensure all parallel rays converge at the same focal point. Well, coma can also be fixed by combination of lenses with different curvatures.